So let's get straight into observing how the join tool works in practice. Firstly, we will need two datasets that we're looking to perform a join on. Therefore, we will drag two input tools onto the canvas. The first input tool we will connect to a dataset called tutorial data, which contains information on individuals such as their name, birth date, gender, and email. The second input will be on a dataset called tutorial data addresses, which contains information such as phone numbers, address information including city, state, and zip information. Now let's suppose that we have been asked to obtain the names of individuals who live in the state called Hertfordshire. Now for those who are familiar with UK geography, you'll be familiar that Hertfordshire is actually a county in the UK, but for the purposes of this dataset, it is classified as a state. So what options do we have when it comes to obtaining the names of individuals who live in Hertfordshire? Well, firstly, we could go into the tutorial data addresses data and filter for Hertfordshire within the states column. This will then bring back a list of user IDs, which we could then note down and then look up in the tutorial dataset where the names reside. Now this is clearly far too manual and way too much effort, especially if we wanted to do this for 100 different states. As I'm sure you've figured out, we can connect these inputs to a join tool and then join these two tables together. So let's drag a join tool onto the canvas and we can then connect the tutorial data to the L anchor, which will therefore mean we are treating the tutorial data to be our left table. And we can then connect tutorial data addresses to the right input anchor, meaning this dataset will be regarded as the right table. If we then click on the join tool, we are able to observe the configuration window and the options available. Now there are two join options available. We can join by record position, or we can join by specific fields. Now the default option is join by specific fields, and I would personally always recommend using this option when performing join operations. As you will soon realise, we have a lot more control and can disregard the ordering of data in datasets, which gives us one less thing to worry about. Now as we're joining two tables together, we need to establish what field or fields we should use as the joining fields. Now in this example, you will notice that we have a field called user ID that is present in both tables. Now if you're new to the concept of joining data and would like to explore this in more detail, I would recommend joining me on my MySQL Bootcamp course, in which we go through fundamental join concepts through the lens of SQL, which makes for an easier time in conceptualizing joins in Alteryx. So let's go ahead and stipulate that we want to use the user ID from the left table, and we want this to match the user ID in the right table. Now what this will result in is the following. Where there is a match in user ID, for example, let's say that user ID 100 is present in both tables, we will obtain a new output table which contains the columns from both the left and the right table, and the rows which contain user ID 100 will line up on one row. All records that have matches on user ID will form part of the J output anchor, which is denoted by this little icon here. This is the same diagram as the inner join diagram I shared in the prior video. Now where user ID does not match in either table, i.e. where there is a user ID in the left table that is not in the right table, or vice versa, the results will feed into either the L output anchor or the R output anchor accordingly. The L output anchor represents all the data from the left table that did not have a corresponding match in the right table, and the R output anchor represents all the data from the right table that did not have a corresponding match in the left table. The section below provides us the ability to select the columns that we want to feature in the final output from the left and right tables, as well as the ability to change column headers, change data types, change the size of the respective field, as well as provide short descriptions for the column in question. Essentially, it's a select tool embedded in the join tool configuration. Very useful indeed. So for this example, Let's suppose we want all the columns from both tables, and the user ID from the right table will be prefixed with the word right to distinguish itself from the user ID in the left table. When we run the workflow, you can see that when I click on the J output anchor, which resides in the middle of the 3 output anchors, we get an enriched dataset with columns from both tables. The first thing to point out is that this dataset is where user IDs match. So as you can see, as you assess each line, the user IDs from the left table are the same as the user IDs in the right table for each given row. Therefore, we can now state that Aisha van Hengel lives in the city of Zutphen, and Sebastian Madsen lives in Lintrup, and so on. Now, if I click on the left output anchor and the right output anchor, you will notice that there is no data present. This is because every line in the tutorial data had a match with data in the addresses data. So let's change this slightly so you can see an example of how unmatched records get handled. So we will first copy and paste the small workflow we've just created, but this time we will add a filter tool in between the addresses dataset and the input to the right table input anchor of the join tool. We will now filter for only those records that have a user ID less than 8,000. In other words, we are removing user IDs from the right table that are 8,000 or greater to make sure we get some line items that don't match. We will also deselect a few columns from both the left table and the right tables to make our final dataset smaller. When I rerun this workflow, what you will notice is that the J output anchor once again contains the rows that match. However, this time, the L output anchor contains user IDs which are 8,000 or greater. This is because they do not exist in our right table input, seeing as we filtered them out of the right table, and hence were regarded as unmatched and fed into the L output anchor. The R output still has no data in it, because every item was matched with data in the left table. Now at the start, I asked what options do we have when it comes to obtaining the names of individuals who live in Hertfordshire. Well, seeing as we've now joined the datasets together, what I can do is add a filter to the J output anchor of the first workflow and have the condition to be where state equals Hertfordshire. When I run the workflow again, we'll be able to see all of the names of the individuals who live in Hertfordshire, with some towns and cities which are very familiar to me. So try the join tool on some of your own datasets. You simply need 2 datasets which have a joining field that links them together. Now in the prior video, I mentioned the concept of left and right joins, as well as the full outer join. Now so far, strictly speaking, we have only obtained the output for an inner join, which is the J output anchor. But in order to get a complete left join result, a complete right join result, or a complete full outer join result, we need to use the join tool in conjunction with the union tool, which we will see in the next video. Let me finish by stating that, over time, technology has advanced. Data now exists in more forms and places than it ever has done before. And Alteryx is a fantastic option for being able to join disparate data sources together to come away with a consistent, enriched dataset that is ready for onward use, whether that be analytics or subsequent steps in your workflow.